problems based on important topics of electrochemistry. So today we'll be doing more problems based on Faraday's constant and electricity carried by 1 mole of electron, electric current, or the time taken for the deposition in the process of electrolysis. And we will also check the feasibility of particular reaction on the basis of EMF or cell potential, and we will also decide the product of electrolysis depending upon the type of electrode we have used in different type of reactions with a different concentration. So today we will be doing question number 3.15 to 3.18. The very first question. Let us see the information given to us. The very first information which is given to us is they have given a solution of nickel nitrate is electrolyzed between platinum electrodes. So inert electrodes are there using a current of, the value of current is given as 5 amperes for 20 minutes. So time is also given as 20 minutes, and what we have to calculate, what mass of nickel is deposited at cathode. So we have to find out mass of nickel deposited at cathode. Okay, so on the basis of given information, first we will find out quantity of electricity passed, because only then we will be able to calculate the other parameters. So quantity of electricity passed, which is we call it depicted with Q, that is quantity of charge, and this is equal to I into T. Okay, that is current and the time taken for the passage of that particular current. So in our case, quantity of electricity passed will be calculated as current is given to us, that is 5 ampere, and time taken is 20 minutes. So it will be 20 multiplied by 60, because we will be writing the value of time in seconds. So we will be getting 6,000 coulombs of charge or quantity of electricity which is passed. Now next information, your electrode is an inert electrode, so they will not participate in any reaction. And if we want to show the reaction, then reaction is nickel nitrate. We are having a solution, so we will write down nickel nitrate in aqueous form will give you Ni2 plus ion, that is nickel ion in the aqueous state, that is in solution, and nitrate ion NO3 minus, and to balance the positive and negative charge we will put 2 here. So these are the negative ion in the solution. Now we will write down the electrode reaction. Electrode reaction. Okay, so in this case what we are having, positive ion as the nickel ion, and positive ion will be attracted at cathode. So this we are showing the electrode reaction for cathode, because cathode is the negative electrode. So therefore these nickel ion, that is Ni2 plus aqueous, or nickel ion in the water, will take electron from the cathode, because cathode is negatively charged, and they will be converted to the metal. Okay, and this is the main reaction at electrode. And for calculating the mass deposited, because we have to find out the mass of nickel deposited. So to calculate the mass, we should know the molar mass of the substance which is being deposited here. Here nickel is deposited, and the molar mass for nickel is 55.7 gram. This is the molar mass. Okay, so we will calculate with the help of this value. Have a look here. When we are having 1 ion of nickel, for the reduction of 1 ion of nickel on cathode, we need 2 electron to get 1 nickel metal. Okay, and which is equal to 50, which is having the mass 58.7 grams per mole, because it is molar mass. Okay, so but for this process we need 2 moles of electron, that means 2 Faraday of charge is required. So what we will write here, that 2 into 96500 coulombs, that is the value of 1 Faraday, deposit nickel. How much? 58.7 gram on cathode. Okay. So we can calculate, we have calculated the value as 600 coulombs of charge we are passing, sorry, 6000 coulomb of charge we are passing. Therefore 6000 coulomb will deposit nickel, and the value will be, we will calculate it as 58.7 divided by the 2 into 96500 multiplied by the value for which we are calculating. So this will give you the value as 1.825 grams of nickel at cathode will be deposited. So this is your answer. In this case, one thing we have to be very clear for such type of reaction, that when we have used inert electrode, so we are not counting the electrode reaction in this, only ions are taken care of. Next question. In the next question, they have given that 3 electrolytic cells A, B, C containing solutions of zinc sulfate, silver nitrate and copper sulfate respectively are connected in series. Okay, so I have depicted here with the help of diagram. You need not to draw, but this is just for your understanding. So we have 3 cells A, B and C. In A cell we have zinc sulfate, in B cell we have silver nitrate, and in the C cell we have copper sulfate solution. Okay, and they are connected end to end, that is in series. Therefore equal amount of current is passing in all 3 electrolytic cell. Okay, now second part of information, steady current of 1.5 ampere was passed through them. Okay, so how much current we are passing? We are passing 1.5 ampere of current with the help of this battery. And what they are saying, the current is being passed for a specific period of time until 1.45 gram of silver is deposited at cathode of cell B. So how much silver is deposited? Silver in the B cell, silver deposited is the second information given, which is equal to 1.45 grams. Okay, how long did the current flow? We have to find out this. So we have to use this value of current and this mass of silver deposited, and what we have to calculate, how long did the current flow and what mass of copper and zinc were deposited. Okay, one idea in this case which you have to keep in mind, since all electrolytic cells, that is A, B and C, are connected in series, same amount of current will pass through each cell. Okay, but and the time taken will be same because they are connected in with each other. But in this case, different amount of substance will be deposited in case of different cell, because different species are there. One have zinc sulfate, another silver nitrate, and the third one is having copper sulfate. So the very first step is that we will try to find out in how much time silver, which is 1.45 gram, is deposited. In the same time, there will be a deposition in cell A and cell C. Okay, so indirectly then with the help of this time we will find out quantity of zinc in cell A and quantity of copper in cell C. So the very first part, in cell B, we will start with cell B because indirectly for A and C we will find out with the cell B information. So in cell C B, What is the reaction? Reaction already we have written. That is, your silver nitrate is there, therefore we have silver ion and nitrate ion. And these silver ion, that is Ag plus aqueous, which are present in the medium, they will undergo reduction at cathode, that is negative electrode, and they will take electron from cathode and will be converted to the silver metal. Okay, and we have to remember in each case what is the molar mass of species which are being produced. So the molar mass for silver is 108 grams per mole. Okay, so we will find out then indirectly the quantity that we need. 1 mole of silver require, if we want to deposit 1 mole of silver, it will require 1 mole of electron, that is 1 Faraday of charge. Okay, why? Because one ion need 1 electron. So 108 grams of silver is deposited by 96500 coulombs of charge. Therefore, a quantity is 1.45, which is given in your question. Grams of silver will be deposited by, we will write it as 96500 divided by 108 and multiplied by your 1.45. Okay, so you will be getting the value as 1295.6 coulombs of charge is needed for the deposition of this very amount of your silver. Okay, now this coulomb of charge will help you to find out in how much time. So we know that charge is related to the current and the time taken by this. So therefore we will write time taken will be equal to Q over I, that is charge divided by electric current. Now in our case, your time taken, therefore, which is T, we can write it as coulombs of charge. We have calculated 1295.6 coulomb divided by current is 1.5 ampere. It is given in your question. So you will be getting the value 863.7 seconds. Okay, this is the time taken for the deposition of your silver. Okay, now we will apply indirectly this in case of other two cell. So what we can do for the cell 1 and cell 2, just a moment. Okay. Now for the cell, first one is your cell A. That is in case of zinc. So in cell A. Cell A is having zinc. So in case of cell A, we are having this reaction. Zn2 plus 2 electron will give you Zn. Okay. And the molar mass of your zinc is equal to 65.3 gram per mole. Okay. So we will find out zinc deposited by 1295.6 coulomb charge is equal to 65.3 divided by 2 into 96500 multiplied by 1295.6. Why we have written 2 into 9650? Why? Because have a look here. For 1 mole of iron we need 2 mole of electron, therefore we are putting this value here. Okay, and so you will be getting answer here as 0.438 gram. Okay, so this is your answer in case of zinc. This is the amount of your zinc metal deposited in case of cell A. Now we will do for cell C, that is copper. So in the case of copper we will write similar type of reaction. Cu2 plus ion will take electron to give you Cu metal, and the molar mass for Cu is equal to 63.5 grams per mole. So therefore copper deposited by 1295.6 coulomb of charge will be equal to 63.5 multiplied by 1295.6 divided by your 2 into 96,500 coulomb of charge, and this is equal to 0.426 gram. Now in this case we have to have the same idea as we did in case of zinc, that when we have 1 mole of copper ion, you will require 2 mole of electron or 2 Faraday of charge to get this quantity. Therefore we are using here 2 into 96,500 coulombs. So this is your answer for the question 3.16. I hope it is clear. Next one. In the next question, we have, using the standard electrode potential given in the table, predict if the reaction between the following is feasible. Now I have written here your standard electrode potential from the table 3.1 of your NCERT book. Okay, so these are the values which we require according to the reaction we will be doing in this case. So they have given you different combination, and according to the combination of electrode we have to tell whether the reaction will be feasible or not. Okay, we have to check the feasibility of the reaction. Now before calculating, one idea always keep in mind that a reaction is feasible. Feasible means spontaneous. If your EMF, that is cell potential, is positive, or your E naught cathode minus E naught, that is standard electrode potential of cathode minus standard electrode potential of anode, this is giving you a positive value. If this is giving you a positive value, that means reaction is feasible. Okay, so this is the criteria for the feasibility of the reaction. So this criteria we will try to check in each and every combination which has been given to us. For the first one, so in the first one they have given you ferric ion with iodide ion. We will write down first the equation for this and then we will be calculating. So the reaction is your ferric ion, that is Fe3 plus ion in aqueous state, will react with I minus ion in aqueous state to give you ferrous ion, that is Fe2 plus ion in the solution, and iodine, that is half of I2, because we have here molecule. So in our case, when we check you're from Fe3 plus to Fe2 plus, this process is what? This is reduction, and this one, that is I minus to I2, is oxidation. Okay, so therefore we will calculate E cell according to this. Therefore E cell is equal to E naught Fe, that is cathode, Fe3 plus to Fe2 plus minus E naught for half I2 I minus. So therefore we will put down the values here. For iron, the value is this one, that is this value. Just a moment. For iron, this is the value, and for iodine, this is the value. So we will put down the values here. It is plus 0.77 volt. Always when you are writing the value of electrode potential, do write down with the along with the sign plus or minus to avoid any confusion while calculating the value of E cell. So you will be getting 0.23 volt, and this value is what? Positive value, that is plus this. Therefore the first one is what? First reaction is what? Is feasible. So the first one is feasible. This is the answer for the first one. This is a feasible reaction. Okay. Now the second one. Silver iron. So again we will write down the equation for this. Reaction will be Ag plus aqueous plus copper metal will give you Ag silver metal plus copper iron and Cu2 plus iron in the aqueous state. Now in this case we'll check the oxidation and reduction. So here silver iron to silver metal is the reduction, and this is the value for your electrode potential, and the second one, your copper to your iron, it is the oxidation, and so therefore this is the value in this case. So we will put down the value here. E cell or the EMF will be equal to E naught cathode. Cathode in our case is silver, so Ag plus to Ag minus E naught for Cu2 plus to Cu. This is equal to plus 0.80 volt minus your plus 0.34 volt. Value will be as 0.46 volt. This is positive value. So again this reaction will be feasible because we are getting the positive value. Okay. Now the third one. In the third reaction we are having Fe3 plus ion in the aqueous state, and we are having bromide ion again in the aqueous state, and you will be getting Fe2 plus ion in the solution and bromine molecule Br2. So we will do in the same manner. E naught cell we will be calculating here again. Now in this case your iron, for iron we have already, for bromide one we will mark the value. So this is the value for your bromine. Therefore we will write down here in the same manner. So this is bromine to bromide ion to bromine molecule, and for iron already we have the value here. So this is the reduction process. In case of bromine we have the oxidation process. So E cell is equal to your E naught Fe3 plus to Fe2 plus minus E naught your Br2 half to Br minus. Now here the value is for iron 0.77 volt. This is positive value, minus 1.09 volt. This is the value in case of bromine. It is given here. So this is again positive value. So you will be getting here minus 0.32 volt. Okay, here negative quantity is greater, so that means this reaction is, this is negative. Okay, therefore this reaction is not feasible. And if you want to make the reaction feasible, then we have to switch anode with cathode. Okay, so we have to flip their role. Only then reaction will become feasible and we will be getting the positive value. Now for the fourth one, in the fourth case we are having silver, that is your Ag solid, plus Fe3 plus, that is ferric ion in the solution. We will be getting silver ion and your Fe2 plus, that is ferrous. Okay, now in this case again we will calculate the E naught cell. It is equal to E naught Fe3 plus 2 Fe, because iron is having the reduction process, cathode, minus E naught Ag plus 2 Ag, and we will be having this value as plus 0.77 volt minus 0.80 volt, and we will be getting value as minus 0.03 volt. So again the value is negative, therefore it is not feasible. Okay, now the last one. In the last one we are having a bromine molecule, that is Br2 in aqueous, plus your Fe2 plus aqueous. Okay, to balance I'm writing here 1/2 will give you Br minus aqueous plus Fe3 plus aqueous. So your from Fe2 plus to Fe3 plus is oxidation, while bromine molecule is being reduced to bromide ion. Okay, so therefore here E naught cell is equal to E naught bromine to bromide ion, that is your cathode where reduction is taking place, minus anode E naught Fe2 plus, sorry, 3 plus 2 Fe2 plus. Okay, so we are having here the value as plus 1.09 volt minus this value is plus 0.77 volt, and we will be getting 0.32 volt, that is positive value. So therefore this reaction is feasible. Okay, it is spontaneous. Question is, predict the product of electrolysis in each of the following. They have given you 4 reactions and you have to find out the product of electrolysis. Now always remember that the product of electrolysis depend on few parameters. First is type of electrode. If electrode is reactive, it will be involved in the reaction at anode and cathode, and it will compete with the other species. If it is inert like platinum electrode, then it will not be taken care of. It will not take part in any reaction. Now concentration of solution. So we have different type of product depending upon we have dilute or concentrated solution of the electrolyte. And lastly, the standard electrode potential. The value of standard electrode potential will decide which species will be oxidized at anode and which one will be reduced at cathode, depending upon the value of standard electrode potential, which is reduction potential. Okay, so the first one, we have an aqueous solution of silver nitrate with silver electrode. Now in this case we have silver electrode. Silver electrode means what? These are the reactive electrode, and therefore they will take part in the reaction at a specific electrode. Okay, so we have to keep in mind that silver electrode will also be involved in the reaction. Now they have given you the aqueous solution of AgNO3, so this will ionize in the solution to give you silver ion in the aqueous medium, and your nitrate ion NO3 minus aqueous. Okay, Side by side, we are having ionization of water also. That is, your H2O will get self-ionized as H plus and OH minus. Okay, so we are having basically 4 types of ion in the medium. Now we will write down the reaction at cathode. Cathode, we know, is the negative electrode in case of electrolysis and or connected to the negative terminal of the battery. Therefore, positive electrode will be attracted. So the electrode which will be attracted towards this will be H plus ion and Ag plus ion, and we will write down the reaction for them. So for in case of silver, your Ag plus ion from the medium will take electron from the cathode to give you silver metal, which will be deposited at cathode, and the second reaction which will be competing with this will be H plus plus electron will give you half H2. Okay, now this reaction we can write in terms of the reduction of water also. So H2O plus electron is giving you half H2 plus OH minus. Okay, here we have to keep in mind that we are having the ionization of water while writing the second equation. So for the first reaction, your standard electrode potential, that is E naught, for example we take it as 1, is equal to plus 0.80 volt, and for the reduction of water we are having E naught value, suppose it is E naught 2, it is equal to minus 0.83 volt. Okay, now we will compare these values. That is your E1 naught, that is for the reduction of silver, is much greater than the E naught 2, that is reduction of water, because standard electrode potential is reduction potential. So silver is having higher tendency to get reduced. Therefore, silver will be deposited at cathode. This is for the first part, that is silver will be deposited at cathode. Now we'll do the second part of the reaction at anode. Now anode is your positive electrode or connected to the positive terminal of the battery. Therefore, ions which will be attracted will be your OH minus ion and nitrate ion. Okay, now we will write down the reactions in each case. Your just a moment, this is the reaction which will take place. Now your silver ion will be produced also in the medium by the oxidation of electrode, that is anode will itself dissolve to give you Ag plus plus electron. Okay, and this is what this silver solid is coming basically from anode, because anode is reactive electrode, it will take part in the reaction, and for that E naught, for example 1, is equal to, or it is better to write the other value, E naught 3 is equal to plus 0.80 volt. Okay, now for the second reaction which we will be having here, because we are having OH minus ion, therefore we will be having what? Reduction of water, oxidation of water. So H2O, that is half O2 plus 2H plus 2 electron. This is oxidation of water, and E4, for example, for this is plus 1.23 volt. Okay, so this is the second value, and lastly we are having nitrate ion also, your nitrate ion, and we are expecting oxidation of these also. Okay, but these nitrate ion will not undergo oxidation. Why? Because your OH minus ion is having greater tendency over nitrate ion to get oxidized at anode, and nitrate is very stable ion with nitrogen in its highest oxidation state, so it is not easy to oxidize nitrate ion. So this ion will not be competing And in the other two reaction, we will be having, we will compare the value of E, that is your, in this case, these values we will compare. So what we have here, your E naught, that is for third one, E naught 3 is less than E naught 4. Okay, therefore your silver will dissolve from anode to give Ag plus ion in solution. So this is the reaction at anode. At anode, we will be having this reaction because it is having lower value of electrode potential. Therefore, it is having higher tendency for oxidation. So always remember, higher the value of electrode potential, which is reduction potential, higher the value of higher the tendency for reduction, and lower the value of electrode potential, then higher the tendency for oxidation. Okay. Now the second one. This one is more or less same, an aqueous solution of silver nitrate, but the difference is that in this case we have taken platinum electrode, and platinum electrode means what? They are inert electrode. They will not take part in the reaction, so will not take care about these electrode for the reaction. Okay, first we will write down reaction at cathode. Cathode is your it will have the same reaction as we did in the previous case, negative electrode, and here we will be having competition between H plus ion and your Ag plus ion, and the reaction which will take place will be your Ag plus ion from the solution will take electron to give you silver metal. Okay, and the reason is the same as in the first case. So silver will be deposited, Ag will be deposited at cathode. Why? Because standard electrode potential for silver is what? Greater than that of water. Okay, so this is the reaction. Now at anode, we will not have any reaction because of the electrode. So we are having only competition between your OH minus ion and nitrate ion. Okay, and in this case your nitrate ion again will not undergo oxidation. Reason I have mentioned already. So what we have in this case, at anode we will be having oxidation of water, that is your water molecule will give you half O2 plus 2H plus ion plus 2 electron. Okay, and the reason for this is that your OH minus has lower discharge potential, that is reduction potential, and reason for this is that as your nitrate ion NO3 minus will not undergo oxidation, as it is in highest oxidation state. So this will be the reaction that will take place, and therefore what we have, your oxygen gas will be evolve will evolve at anode. So this is the reaction, this is the oxygen gas which will evolve at anode, and at cathode your silver will be deposited. This is the reaction in the second case. Now in the third case, we are having a dilute solution of sulfuric acid with platinum electrode. Platinum electrode, again inert electrode. So in this case we will write down the reaction. When we have sulfuric acid solution, we are having in the medium H plus ion and sulfate ion in the aqueous state. So we will write down the reaction. First we will write down at cathode. At cathode we are having competition between two reaction. In the medium we are having H plus ion. So these H plus ion will take electron from cathode to give you hydrogen gas. Okay, and for this E naught value is 0.0 volt. Okay, suppose again this is first value, and your we have another reaction, that is water molecule H2O will also be undergoing reaction, that is reduction by taking electrons, for example 2 here, so we'll be putting 2 electron to give you H2 plus 2 OH minus. Okay, and for this your E2 naught is equal to minus 0.83 volt. So in this case, how we are relating, your E1 naught is greater than E2 naught. Okay, so therefore H plus ion will get reduced, and therefore we will get H2 gas liberated at cathode. Okay, in this case H2 gas will be liberated at cathode. Okay, now the second part, at anode. When we write the reaction for anode, at anode we are having again two reactions. First is anode, we have oxidation. So first we have oxidation of water to give half O2 plus 2H plus 2 electron, and for this suppose E3 value is plus 1.23 volt. And another reaction we have, because sulfate ion are also there in the medium, they are negatively charged ion, so these ion will be converted, undergo oxidation by the loss of 2 electron. For this your E naught value is approximately 2.0 volt. Okay, so here in this case your E3 naught is less than E2 naught. Therefore, H2O will be oxidized. Okay, and as a result, what we have, O2 gas is liberated at anode. So in this case, at cathode we'll get hydrogen gas, and at anode we'll be getting the oxygen gas. Now the next question, an aqueous solution of CuCl2 with platinum electrode. Platinum electrode, again the inert electrode. So we will write down the reaction again. First we will show the dissociation of CuCl2 in aqueous medium. We are having Cu2 plus aqueous and 2Cl minus aqueous. Okay, so we will write down the reaction at cathode, which is the negative electrode. So therefore positive ion will be attracted, and therefore we'll have Cu2 plus will take electron from cathode, will give you Cu metal, and for this E naught value is 0.34 volt. And side by side we are having reduction of water also. So 2H2O plus 2 electron will give you H2 plus 2OH minus, and for this your suppose E naught value is minus 0.83 volt. Okay, now we will compare the value. Your E1 naught is greater than E2. Therefore, copper will be deposited. Copper will be deposited at cathode, and this is the reaction that will take place. Now the second part, at anode. Anode is the one which positive one, therefore it will attract the negative ion. Therefore your chloride ion will be attracted and you will get chlorine gas by the removal of 2 electron. For this E naught value is plus 1.36 volt. And second reaction which will compete will be the oxidation of water to give you oxygen gas by the removal of electron. And for this E naught value is plus 1.23 volt. Okay. Now this value, here compare the value, your E naught for chlorine, for water is, that is fourth one, is less than E naught 3. Therefore H2O should be oxidized and O2 should be evolved at anode. Okay, but this will not take place. Okay. Why? But due to over potential of oxygen. In case of the oxidation of water, reaction is kinetically very slow. Therefore, oxygen gas will be evolved not at the given value but at some other value which is much higher than this value. Therefore, due to over potential of oxygen, what we have, Cl2 gas will be evolved. Okay, so this is the answer. Cl2 gas will be evolved and the reaction for this is this one. Okay, and the reason is because of the over potential in case of oxygen. So this finishes our chapter. You can go through other videos of the same chapter to check the other questions from the same exercise. I hope it is clear. This is all for today.